Welcome to EPG Pathashala. My name is Dugirala Vasanta. I am on the teaching faculty of Department of Linguistics in Osmania University, Hyderabad. This is course 10, Psycho-neurolinguistics. Today's lecture relates to module 23 on dyslexia and dysgraphia. They are also referred to as alexias and agraphias, but dyslexia is more commonly used. The main objective of this lecture is to discuss some concepts relating to reading processes and writing systems, and secondly to talk about acquired reading and writing disorders following brain damage. In any language, understanding the relation between letters and their corresponding sounds is an important basic skill necessary for successful reading and spelling of words. We have less difficulty spelling words that are based on predictable letter sound correspondence. That is, if one sound, that is phoneme, has an equivalent one grapheme corresponding to it, it is much easier to remember and read it and also spell it. Let's look at some examples from English about different type of words. Regularly spelled words. Suppose you take the word hat, H-A-T are the phonemes. Now, corresponding to these sound units, you have the graphemes H and then A and T. So, there is a direct one-to-one correspondence. These are called regular words. So, other regular words like say stop, van, lot, ten, top, these are all regular words because there is one phoneme corresponding to one grapheme. So, we tend to use this regularity between phonemes and graphemes even to read pseudo words or non-words which are created for using it in psycholinguistic, neurolinguistic experiments. For instance, if you are asked to repeat a non-word like coal or nin or token or something like that, we use this knowledge about phoneme-grapheme relationships and pronounce them like that. K-O-L is coal, N-I-N is nin, like that. But the English doesn't have only regular words like this. There are some irregular words. At least 13% of the English words have irregular spelling. So, for instance, words like yacht, which is spelled Y-A-C-H-T, straight, friend, value, stomach. So, the spelling do not reflect the sounds the way we pronounce them in these words, and therefore they are called irregular words. Most theories and models of reading English are based on how to account for our ability to read regular words. Let us look at one well-known and well-cited model of reading in relation to English. It's called dual root cascaded model or DRC model. DRC model is based on the premise that there are two separate roots. One is a whole word lexical root and the other one is a phoneme grapheme or grapheme phoneme root depending on whether we are reading or spelling. The lexical whole word root goes from print to speech in reading and speech to print in spelling, and it goes directly to semantic system. Whereas the non-lexical root makes use of conversion from phoneme to grapheme or grapheme to phoneme depending on the task that we are involved in. Look at the picture of DRC model on the screen. The topmost, it starts with print. Our eyes pick up the visual features of letters. There are letter units which make us identify the graphemes. If you go right, you go into the GPC root, that is grapheme phoneme conversion root. So, you identify graphemes, you think about the phonemes, you convert them and you go into phoneme system and you produce the speech. On the other hand, after going through the letter units, you can search your orthographic lexicon. Your mental lexicon has information about phonology, morphology, orthography, the writing rules of your language. So, orthographic lexicon, you access the meaning from the semantic system, then come to phonological lexicon and then the phonemes and then you produce. So, these are the two roots. When you are looking at it, to your right would be the GPC root and the left side will be the lexical root, whole word root. So the whole word or what they call lexical root is required for processing well-practiced familiar words, okay, including irregular words. On the other hand, you need non-lexical phonological root for processing novel. You have never seen them. They're non-words or they're pseudo words, regular words, which are not mentally stored. Some of the non-words, you don't store them. They're not words, so they don't exist in the lexicon. So you need a phoneme grapheme conversion to process such words. So DRC model is capable of, it has been shown through decades of research, the DRC model can simulate patterns of acquired alexia and agraphia. Alexia is the reading disorder, agraphia is writing disorder. So they've developed this DRC model to, that is artificially, you first of all make a computational model of DRC. You artificially lesion one root and the computer produces errors which are similar to a patient's mistakes. So that's how they developed this model. But recent researchers are of the opinion that DRC model may not work well for languages which are very different from English from the point of view of the writing system. You will learn, I think in psycholinguistics there's a module about writing systems, and I will say a few more things about how languages differ with respect to writing systems they adopt. So basically DRC model may not fit languages which don't use alphabetic system. English uses alphabet, and if your language does not use alphabetic system, you may not be able to explain reading or reading disorders using DRC model. But the Kohlhardt, who is one of the neuropsychology psychologists who is involved in developing DRC, has this to say about DRC model. The general architecture of this system must be modular, with distinct phonological and orthographic modules or lexicons, and a semantic system connected to both these modules. And in addition, a separate system of non-lexical rules specifying correspondence between phonemes and graphemes. No theory of reading that does not have such an architecture can be reconciled with what we know today about acquired dyslexia. So it's a very strong statement from the developer of DRC model, but you will realize that more and more criticism is being leveled in recent years against DRC model from languages which are very different from English. So what do these people who are questioning modular DRC model have? What are the problems? Many of them are actually connectionists. Connectionist models of reading postulate that a single processing step with bidirectional flow of information. So what does modular model do? It says you pick up the letter units and then you identify the letter, transform it into the phoneme, so grapheme phoneme correspondence, or you go search for those letter units in the lexicon, orthographic lexicon, go into semantic system. That's how everything is modules, separate modules. In the connectionist models of reading, there is possibility for bidirectional flow of information. Okay, that is input units, letter shapes or sizes or whatever, they can draw information from above, meaning or word or whatever. Such models can simulate reading aloud of both exceptional words and non-words. The link between various nodes, you can use the word node in a connectionist system when it comes to reading to mean letter features can be one node, full letters can be one node, words can be one node. Okay, so these various nodes are either excitatory or inhibitory. So when one feature or a letter or a word unit is activated, it either enhances or suppresses activation of other units, so that you will identify the intended word, correct word. In such a system, letters or phonemes are more easily recognized if they receive information from top down, from contextual based information. Because there is bidirectional flow of information, connectionist models say that reading also draws on our world knowledge or higher level knowledge, and you don't have to put all the features of the letters together to identify what is a D and what is a B. Let's now look at what is the neural basis for reading. I'll just share with you one recent study based on 14 patients with brain tumors. They were asked to name pictures, read words, and read pseudo words. And they did electrical stimulation on these patients in order to localize which parts of the brain are getting activated when they're naming pictures or reading words or reading pseudo words. The cortical network for reading English words based on the study involves many of the perisylvian areas, sylvian fissure or the lateral fissure, which differentiates frontal from temporal lobe. So, frontal, temporal and parietal lobe areas, all those three lobe areas around the sylvian fissure seem to be involved in reading. Examine the figure on the screen. You will notice different colored circles imposed on the brain. You have green circles which correspond to areas activated when we read pseudo words. They are artificial words created purposely in research. The blue ones is the area which activates when we are reading real words. The red circles represent areas which are activated when we read both kind of words. Notice that all the circles appear or localized to perisylvian area covering parts of frontal lobe, parietal lobe and temporal lobe. So, in some ways we can say that these areas are the cortical network involved in reading. So, after this, you need to now think about what are acquired reading and writing disorders. So, reading disorders are called dyslexias and writing disorders are dysgraphias. But they can be developmental dyslexias and dysgraphias and acquired dyslexias. In this module, we are limited to the discussion is limited to acquired disorders of reading and writing and not the developmental ones. And acquired disorders that are associated with aphasias is what we will be discussing. Acquired dyslexia if the problem is confined only to reading, dysgraphia if it is confined to writing. So, reading and writing disabilities can also be developmental, that is children in the course of learning their language, learning to read and write can experience a lot of problems. This module is not about developmental dyslexia or dysgraphia. It is only limited to discussion of acquired dyslexia or dysgraphia, which is associated with aphasias, stroke aphasias. So, let's look at some types of acquired dyslexias and dysgraphias. The major types are pure acquired dyslexia without any dysgraphia. That is one type. Here, patients have difficulty reading all kinds of words, whether they are regular or pseudo or irregular or whatever. Patients spell the words by naming each letter. They have to name the letter in order to spell, in order to read also. So, damage is likely to be in the left hemisphere occipito-temporal cortex. The researchers have shown patients who are diagnosed with pure alexia without agraphia have problem in occipito-temporal cortex in the left hemisphere. The second major type is called surface dyslexia dysgraphia. These patients rely heavily on phonological processing because in these patients the lexical root in the DRC, the whole word root is damaged. So, they can't access orthographic lexicon. So, difficulty is with reading low frequency irregular words which require that root and the root is damaged. So, they make mistakes on those type of words. The third major type is called phonological dyslexia or dysgraphia. Patients with this problem are unable to engage in phonological processing involving non-lexical GPC route. Go back and look at the diagram if you have any doubt. These patients put too much emphasis on unimpaired lexical route. Because phonological route is damaged, they are relying completely on the lexical route. So, when asked to read unfamiliar or non-words or pseudo words, they regularize them. So, you tell them, don't worry, I am going to give you some letters. Don't worry whether it is a word or not word, just read it. So, I tell the patient, read FLIG. So, instead of reading it as flig, they read it as flag, because they are relying too much on the whole word route. And flag makes sense, flig doesn't make any sense. So, that's how you identify the problem is more phonological dyslexia. They also perform better in both reading and spelling of highly frequent words compared to low frequency words. There is another variety of dysgraphia called deep dyslexia or dysgraphia. This condition is characterized by patients' inability to read pseudo words and non-words aloud. They tend to produce visual, semantic and derivational errors, or what are known as parallaxias. So, if you, they will read mouth as month, singing as, for poem, or sleeping for sleep, like that. These patients are said to rely on, they rely more on the right hemisphere. And you have learned in the other modules in the neurolinguistics that right hemisphere processing is holistic and it's very different. It's not analytic like left hemisphere. So, some of these errors are attributed to patients relying more on the right hemisphere. But I have already pointed out that reading is not a universal ability, which cuts across all languages. Reading depends upon the particular writing system. So, let's move on to the topic of how writing system influences reading. You know that the major types of writing systems are alphabetic systems, where consonants and vowels are separated in writing. In spelling English words, consonant is separate from vowel, right? So, good example of alphabetic writing system is English. Now, syllabic systems like Chinese, Japanese especially, not Chinese, Japanese has two different types of systems. One is called kana and one is called kanji. So, the kana uses a whole syllable is what is, each graphic unit is a syllable, not a phoneme, alright. So, they rely on either full syllable or what is known as mora, which is a unit of time. So, if there are two long vowels, they have two moras. Okay, it's a timing unit. One example of syllabic system is Japanese. On the other hand, there are systems which make use of, which are partly syllabic, partly alphabetic. They are called alpha syllabaries or semi-syllabic writing systems. You might want to know that most Indian languages have semi-syllabic writing systems. So, Devanagari of Hindi is a semi-syllabic system. As you know, each written unit is called Akshara. So, sometimes Devanagari is also, Devanagari and many of our Indian language writing systems are called Akshara systems, which is at the level of syllable. That is, we don't write vowel separately from consonant. You know, the vowel is incorporated in the consonant. So, on the other hand, as opposed to this, you have Arabic, which makes use of consonantal systems. In other words, Arabic represents only consonants, no vowels. Vowels have to be, you have to figure out the vowels from the context. So, it's called consonantal system. You can also have the entire word or a whole meaningful morpheme as the unit, and good example of that is Chinese characters. Chinese, each unit you see in writing is not a phoneme, it's not a syllable, it is a full word, or a, like tree will have one symbol written there. So, it's a logographic system. Now, We have to now talk about what happens, what kind of dyslexias and dysgraphias can occur in different writing systems. So, so these are the different writing systems. Now we need to understand what is the impact of these writing systems on understanding dyslexias and dysgraphias. But to do that, we need to engage with one more concept called orthographic depth. That is, orthographies are classified. So far, the classification is about what is the minimal unit of writing, whether it is phoneme or syllable or whole word or whatever. But orthographies are also classified as either deep or transparent. They are deep when there is no correspondence between graphemes and sound units, as is the case with Chinese. Chinese, you see entire word printed as one character. Japanese kana script is considered as transparent because you say the sound and that's what you write. It's a one-to-one correspondence between phoneme and that syllable they write, right? But kanji it is not so. Kanji is not as transparent as kana. Among the languages with alphabetic scripts, earlier I said English is the best example, but with there are many other French and many other languages use alphabets, but English is considered as deep because the type of the complexity of syllable structures in English is very high compared to other languages which use alphabetic systems. Not only complexity of syllable types, but correspondence between grapheme and phoneme is also very complex. So, among the alphabetic writing systems, English is has considered as deep. Orthographic depth is more compared to other languages which use alphabetic systems. Now, this orthographic depth hypothesis predicts the nature of dyslexia or dysgraphia we can expect in patients. What is the prediction? It says that the severity of the reading and writing problem is more in deep orthographies compared to transparent orthographies. So, the writing system of most of our languages, not only the Devanagari of Hindi, but the alphabet syllabary used with Telugu, Kannada, Malayalam, Tamil, many of our Indian languages are relatively transparent. They are not deep like English because what we are saying, the sound is being written as it is with minor modifications. So, what does it mean? So, what happens? What does dyslexia or dysgraphia mean in our languages? Just because, of course, there are people who say that it doesn't exist. Our children don't have dyslexias and dysgraphias as much as children who are trying to learn English. But that's not quite true. But now we are talking about acquired dyslexias and dysgraphias, that is reading and writing problems after brain damage. So let's take an example of actual patient. Miss S was 36 years old. She had PG level education. She was teaching English before she had the stroke, and neurologist diagnosed her to have Broca's aphasia involving the lesion is confined to left hemisphere frontotemporoparietal cortices. She exhibited surface dyslexia with lots of visual approximation errors in reading English words. So the data is presented on the screen. Please examine the data to see the kind of errors she made when she was reading English words. She read triangle, Barbie, B-A-R-B-E for barber, and failed to discriminate among F, B, D. She could not spell words such as pencil. She could not spell government. Writing was slow. She misspelled alphabets like I, J, and K. She could not write to dictation words like safety pin, scissors, and look at the mistakes she made while reading English words. The target word was realm. You know, the spelling of realm is R-E-A-L-M. The patient's response was R-E-E-Y-A-L-A-M. Realam. So, rel is read as realum, SEW, su is written as SUE, castle is read as, read and spelled also as KASTEL, loss as LOS, gross as GROSE, lie as LII, soul as SOWL, like this. You can look at it. Then they tried testing her in oral reading of Kannada, and I believe it was much better than English. So the point to be noted here is that the impact of brain damage on reading differs depending upon the kind of writing system that is involved in the language. Also remember, notion like irregular words makes little sense in relation to Kannada or Telugu. You don't have too many irregular words like English has. And therefore, the nature of difficulty of dyslexia in Kannada would be very different from that in English. Look at the screen for another example of a 34-year-old Broca's aphasic patient, Hindi speaking patient. He was asked to write to dictation. So the examiner, the neurologist, told him to write Khoon, Naak, Bal, Gal, Gal, Khel, Rani, Chacha, Thali. Some of these words, those were what he was asked to write. Look at the mistakes he has made. Let me just summarize few of the mistakes in Dysgraphia, in writing mistakes made by 34-year-old Hindi speaking Broca's aphasic. Notice the spelling errors involving secondary graphemes. So, patang, the chandrabindu, the nasality is missing. Patag is written. The na is not there. The na marker is not there. Jahaj became dahaj. Vowel markers are distorted in words like kale, instead of the top marker, the secondary markers are distorted. Khoon, there is a mistake. Murgi became gumr. Gumr it became. So notice other errors. By going back to the spelling mistakes, this patient produced. This was a 51-year-old aphasic with PG level education. To summarize today's lecture, I've started with examples of the so-called regular and irregular words in English and how a dual root cascaded model, DRC model it's called, it's one of the major models used to explain how reading takes place in English. I've talked about that model and I've pointed out that DRC model may not work to explain reading processes in relation to languages which are very different from English. Then we spent some time talking about the alphabetic systems as opposed to syllable alphabets, or like Indian languages make use of partly syllabic and partly alphabetic systems, like the Akshara languages, like Devanagari is an Akshara language. How reading, is explained in relation to syllables and not in relation to phonemes. And I've talked about what is the impact of differences in writing systems on manifestation of dyslexia and dysgraphia. That if a writing system is deep as it is in English, that is, there is no direct correspondence between phonemes and graphemes, then the nature of dyslexia and dysgraphia is different. It is probably more severe compared to transparent systems, which is what most of our languages have, writing systems which are more transparent, meaning there is more or less direct correspondence between phonemes and graphemes. So, I have tried sharing a few samples of reading and writing from dyslexic patients in the Indian context, mostly Hindi and maybe some other languages. So, I suggest that you look at the e-text and additional readings to understand if something is not clear in what I have said in today's lecture. Thank you.